In this lecture, I am going to discuss about symmetrical component analysis. A symmetrical component analysis is basically a tool through which you can analyze unbalanced power system on per phase basis. On per phase basis means just by considering one phase, you can evaluate the parameters of other phase. So the technique through which you can analyze unbalanced power system on per phase basis is called symmetrical component analysis. So let us first understand what is the meaning of balanced and unbalanced power system. What is the meaning of symmetrical and balanced three-phase system? And what is the meaning of unsymmetrical and unbalanced power system? For this, I have considered here one three-phase source and one three-phase load. Both are in star connection because similar polarities are connected together. You can see here. And the point at which similar polarities are connected together is called neutral point. And the voltage between line and neutral point will be phase voltage, and voltage between line to line will be line voltage. Already you have studied about phase and line voltage in first year course, and for star connection, line and phase voltage given by this relation. This is for star connection. And for delta connection, because three-phase system can either be connected in star or in delta. For delta connection, line and phase voltage will be equal. And you have studied about star and delta connection in first year course or in the course of machine. So you must revise it for better understanding of this unit. Now, what is the meaning of symmetrical system and balanced system? Let us consider this three-phase load and self-impedance of its phase are equal. If self-impedance of its phases are equal, and if there is any mutual impedance between the phase, and this mutual impedance are also equal, then you will say this load is symmetrical. Similarly for the source. So the meaning of symmetrical means symmetrical in impedance. Each phase will be of same magnitude of impedance. Each phase will has same magnitude of impedance. So, and if there is any mutual impedance between the phase, then that mutual impedance will also be equal. Then only you can say the three-phase system is symmetrical system. So this is the meaning of symmetrical system. Now, what is the meaning of a balanced system? What is the meaning of balanced voltage? Balanced voltage means if this generator gives balanced voltage to this load, what does it mean? It means the phase voltage, or you can say uh, each phase voltage will be of same magnitude. The magnitude phase voltage uh, of phase R, phase voltage for phase Y, and phase voltage for phase B will be of same magnitude. And not only magnitude, but there is second condition also. The phase difference between any two phase will be of 120 degree. Then only you can say that the supply is balanced supply. So balance supply, if three-phase system gives balance supply, it means the phase voltage of this three-phase system will be of same magnitude, and the phase difference between any two phase will must be of 120 degree for three-phase system, and for n-phase system this will be equal to 360 by n. So this is the meaning of balanced voltage. And when you will give balanced supply to the symmetrical load, then obviously the current of each phase will also be same, because current is just is ratio between voltage, phase voltage and phase impedance. And if it is a symmetrical system, then obviously its phase impedance will be same. And if it is balanced supply, then obviously phase voltage will also be same. So V by Z is same for each phase. So you will get this phase current. So in this way, if for symmetrical and balanced three-phase system, you can analyze power system on per phase basis, because each phase has similar characteristics, or you can say phase A current, phase A voltage, phase A impedance will be same as phase Y voltage, phase Y current, phase Y impedance, and will be same as phase B voltage, phase B current, and phase B impedance. So there is no need to analyze all of the phase. You can do analysis through one phase basis or per phase basis only. For example, you have to calculate power for one phase only, which is VI cos phi. And for entire power system, you have to multiply with 3 only. So in this way, you will get total power. So this is the simplicity in symmetrical and balanced three-phase system. But this is not true if your system become unbalanced. So first, let us understand what is the meaning of unbalanced supply. Unbalanced supply means phase voltage magnitude will differ from one another. Suppose generator supply three-phase supply power to the load. But if voltage of phase A is 100 angle 0, voltage of phase B is 80 angle minus 120. 80 angle minus 120. And voltage of phase B is again 100 angle plus 120. So in this example, you can see the magnitude of all phase are not same. Magnitude of phase R differ from phase Y. So this will make unbalanced system. This is unbalanced system. And if you will give unbalanced supply to the load, then the current will also differ. Phase current will also differ from one another, because phase current is V by Z. Uh, Even the load is symmetrical, instead of this, you will get different phase current. And if phase current will differ from another phase, then obviously power will also differ from the other phase power. So you will have to analyze. You cannot analyze power system on per phase basis if your system is unbalanced, if supply is unbalanced. So there is a need of a technique through which you can analyze unbalanced power system on per phase basis, and that technique is symmetrical component analysis. You can do the analysis of unbalanced power system on per phase basis, and the technique through which you can do the analysis will be symmetrical component analysis. And in this unit, we are going to discuss, I am going to discuss about that technique. Now, uh, the second important point before coming to the main topic of this unit is phase sequence. What is the meaning of phase sequence? Uh, Phase sequence is order in which phase voltage will attain their maximum or minimum value. Suppose this is a three-phase supply. This is V angle 0, and obviously this voltage lag uh, voltage A by an angle 120 degree, because its maximum appear after 120 degree from A. So B lag A by an angle 120 degree, and C lag B by 120 degree, or you can say C lag A by an angle of 240 degree. So in this example, you can see that the order in which the phase voltages attain their maximum is A, B, and C. So its phase sequence will be ABC. This is the meaning of phase sequence. This is the meaning of phase sequence. If phase sequence is ABC, it means the phase voltage, maximum value of phase voltage of phase A will be attained first. A will attain first, then B will attain, and then C will attain. The maximum value of A will reach first, then maximum value of B will reach, and then maximum value of phase C will reach. This is the meaning of phase sequence. And if phase sequence is ACB, it means the maximum value of A will reach first, then the maximum value of C will uh, achieve, and then the maximum value of B will achieve. So this is the meaning of phase sequence ACB. In three-phase system, there are only two phase sequence. One is ABC and another one is ACB, if the reference voltage is A. So this is the meaning of phase sequence. And you can clearly see in this diagram. And if I ask you, what is the phase sequence of the waveform which is shown here? So from the waveform, you can easily say, as the phase A reached first to their maximum value, then B, and then C. So its phase sequence is ABC. So this is the meaning of phase sequence. And the second important point is how you will draw phasor diagram for balanced three-phase system. So first you have to write uh, the equation of phase voltage in phasor form. And obviously this phase A crosses the time axis at an angle 0 degree. So the equation phasor form. So equation of this phase A in trigonometric form will be Vm sin omega t. Similarly, what will be the equation for phase B voltage? The equation for phase B voltage will be, this is a function of time, and the equation of phase voltage B will be Vm sin omega t minus 120. Here minus sign represent the phase voltage B lag phase voltage A by an angle 120 degree, because the maximum of B will come after the maximum of phase A, and the angle difference between these two will be 120 degree. And similarly, you can write equation for phase voltage of phase C. This will be Vm sine omega t minus now phase C lag phase A by an angle of 240 degree. 120 plus 120, and since it is lagging, so again it will be minus 240. This is the voltage of phase A, phase B and phase C in trigonometric form. But if you want to write this equation in polar form, then how you will write? You have already studied in first year. This voltage or voltage of phase R will be V angle 0. Here V is the RMS value or Vm by root 2. What will be the voltage for phase Y? The voltage for phase Y will be V, and you have to write the angle through which it is lagging the phase A. It is minus 120 degree. Similarly, you can write the voltage equation in polar form or phasor form for phase C. It is lagging phase A by 240 degree. So you can write the equation of phase C, or you can say of phase blue, B for blue, is V angle minus 240 degree. So in this way you can write this waveform equation in polar form or phasor form. So this is the equation of phase R, phase Y and phase V. R for red, Y for yellow and B for blue. And now you must remember here minus 240 is written as plus 120. I will show you why I am writing this through phasor diagram. If you want to draw phasor diagram, for example, let us consider this is not V angle plus 120. This is V angle minus 240. Now the question is, draw phasor diagram for these three phase voltage. How you will draw phasor diagram for these three phase voltage? Uh, the phase R is the reference. This is VR. This will be VR. Now this Vy, how you will draw this Vy? Uh, since this angle is minus, so you have to draw other vector. And since the sign is minus, so you will consider in clockwise and at an angle of 120 degree. You will get Vy. And what will be the vector for this? So here you can see the angle is minus 240. Minus means in clockwise direction. You have to draw another vector in clockwise direction, but angle from the reference will be 240 degree. Angle from the reference will be 240 degree. So in this way you can get VR, Vy and Vb. This is the phasor diagram for this phasor representation. Now, if you will measure angle in clockwise direction, then vector Vb will appear after an angle 240 degree in clockwise direction. So you can write minus 240. But if you will measure angle in anti-clockwise direction, then vector B will come only after 120 degree, and in anti-clockwise direction you have to use plus sign. So that is why this minus 240 can be written as plus 120. So please do not confuse with these two. Minus 240 is same as plus 120. Similarly, minus 120 will be same as plus 240. So you must remember this. So this is the meaning of phase sequence, and this is the phasor diagram. In next lecture, I will discuss how you will uh, assess unbalanced power system on per phase basis by a technique, and that technique is called symmetrical component.